Welcome to PERT Test Taking Strategies Plug and Chug. This video is going to focus on using the plug and chug strategy on the PERT test. You're going to do that when you see the directions for solve for X, find the solutions, anytime a point is given in a problem. When the directions say to evaluate, but this one's going to be really tricky because this actually falls into real math. But the first part of the strategy or the first part of the problem, you are going to use plug and chug. And then the last one is systems of equations. So if you see the word system, you're going to want to use plug and chug. What is plug and chug? Plug and chug can be used whenever you have a multiple choice test. You are basically taking the answers one at a time and you're plugging them everywhere you see an X in the problem. So you see how we have an X at the very beginning and an X on the other side of the equal sign. If we are going to try if we're going to try answer choice A, which is X equals negative 16, you are going to plug negative 16 into this X and into this X. And when you do that, that is the plug part of the method. Then you're going to chug your way through the problem. And chugging your way through the problem is when you go through and you use the order of operations, or we call them PEMDAS. Parentheses, exponents, multiplication, division. You do that on left to right order, if that's all that's left, and then adding and subtracting. And again, that is left to right order. All right, so let's go ahead and get started. So here I have my answer choices, negative 16, negative 3, 3, and 5. The directions say solve for X. And based on the way my answer choices look, you can see it says X equals negative 16. These are all suggestions that I'm going to take to plug into this equation to see which one solves it. I know which one solves it because at the very end, I will have the same number on both sides of the equal sign, whatever that number may be. All right, so I'm not going to start with the negatives because I don't want to include negatives in this problem. I'm going to go ahead and start with the positives. I'm going ahead and I'm going to try letter C. So I'm trying C, which is X equals 3. So everywhere I see an X in the problem, which is right there and right there, I'm going to replace it with a 3. So negative 14 plus 4, parentheses 3, equals negative 3, parentheses, negative 6 minus 5, parentheses 3, parentheses closed on that one, and then I have a plus 1 at the very end of all of that. So let me try to squeeze that plus 1 right here at the end. Okay, that's the plug portion of the problem. Now I need to actually go through and chug. So I'm going to go through and chug according to PEMDAS. I have parentheses in the problem. This parenthesis just has a number in it, so it just represents multiplication. But if I'm working on the left and the right side, I can work on the left side first. I can go ahead and do that multiplication because I have addition and multiplication, and according to PEMDAS, I do multiplication first. So since I am doing multiplication, I put a blue box around the two numbers that I'm multiplying, a positive 4 and a positive 3. When I multiply positive 4 and positive 3, that does give me a positive 12. Bring everything else down on the left-hand side, and now let's go look at the right-hand side. Over here, I have a number on the outside of the parentheses, but that's represented by multiplication, and then I have this plus 1 at the very end. Inside my parentheses, I have subtraction, but I also have multiplication right here. So I'm going to do that multiplication first. So I'm going to box them in a blue box because that represents my multiplication rules, and it reminds me to only follow my multiplication rules. If you are confused on where this blue box method is coming from, you might want to take a look at PERT Test Taking Strategies, integers. Negative 5 times a positive 3 is a negative 15 because a negative times a positive is negative. Bring everything else down in black that you see in this problem, just like you see it, and then keep working inside those parentheses. I still have a negative 6 minus 15, so I'm going to go ahead and box that in green because I am going to use my adding and subtracting rules. When I have the same sign, which I do in this case, one is negative and so is the other one, you might want to train yourself to see that negative 15 or that minus 15 as a negative sign, I add those numbers. So 6 plus 15 is 21. And because they were both negative to start with, they stay negative because I'm adding and subtracting. If that was multiplication, it would be different. Bring everything else down on the right-hand side. And on the left-hand side, I have 4 plus 12, but, oh, wait, that should have been a negative 14. I'm sorry, I didn't see that. It was blocked by my pencils I was choosing at the time. So on the left-hand side, I have negative 14 plus 12. I'm going to put a green box around those numbers because I have a plus sign that's separating them, and that plus sign indicates I'm going to follow the adding and subtracting rules for integers. And I'm going to look at their signs even further. One of them is negative, one of them is positive, which means I'm going to subtract those numbers. When I subtract them, I get 2. And now I look to the bigger number, which is 14, and since he's negative, that's going to be a negative 2. On the right-hand side, I still have a little bit more work to do before I get down to just a number. So if you look over here, I have multiplication and addition. So we're going to have to multiply first. So I'm going to put a blue box around that multiplication, and I'm going to follow my blue rules. A negative times a negative is a positive. 3 times 21 is 63. And now you're going to bring everything else down that's on that same side. So let's just stop and look at the problem as of right now. It looks like it says negative 2 equals 63 plus 1. All right, so it's getting a little weird here because those don't seem to match up. If I have a negative 2 on the left-hand side and I go ahead and add 63 plus 1, that gives me a 64. Is that true? Does negative 2 actually equal 64? And no, it does not. So what did we just find out? By plugging in a positive 3, our answer is not correct. So x equals 3 is not a possibility. We'll need to try another one of the answers. So either 5 or negative 3 or negative 16. I'm going to try negative 3 this time. All right, so after I go through and I plug in a negative 3 everywhere I see an x, I'm going to go and I'm going to try to do order of operations again. Remember, you can draw your wall and you can work on the left and right side independently. Looking on the left side, I have a plus sign and multiplication. So I'm going to go ahead and multiply those two numbers together. And when I do that, I get a positive 4 times a negative 3. And that gives me a negative 12. And that would have been a blue box if I wrote a blue box around there. So that gives me a negative 12. And I'm going to remember this time to bring down the negative 14 equals. On my right-hand side, I have multiplication and addition. And subtraction. And on the outside of the parentheses, I have addition and multiplication also. But I'm working inside the parentheses right now. So I'm going to focus on that negative 5 times a negative 3. I would create a blue box around that, and I would get a positive 15. Bring everything else down that you see in the problem that is not in that blue box, and continue solving by using PEMDAS. All right, now over here on the left-hand side, I'm over on this side of the equal sign. I have a negative 14 and a negative 12. I would draw a green box around those numbers because they have that negative sign in between it. I'm going to follow those rules. Both of them are negative, and since both of them are negative, I know I'm going to add those numbers. 14 plus 12 gives me a 26, and it's going to be a negative 26 because those two numbers are both negative. Equals. On my right-hand side, I also have another green box inside those parentheses. That should be a green box. And when I add negative 6 plus 15, I notice that one of them is negative, one of them is positive. So I'm actually going to subtract those. And when I subtract those, I get 15 minus 6, and that would give me 9. Now the larger number in this case is 15, so therefore it's going to be a positive 9. And I'm going to wrap him with parentheses because on the outside is that negative 3 waiting to multiply to that. So bring everything else down, that negative 3. And then that plus 1 at the very end. I'm going to put a blue box around negative 3 times a positive 9, and that would be negative 27. Bring everything else down, plus 1, On this side, negative 26 equals, and on the right-hand side, I've got a plus sign there, so that tells me I'm going to put a green box around those numbers. And looking at those numbers, one of them is negative, one of them is positive, so I know I'm going to subtract those two numbers. 27 minus 1 is 26, but it's going to be a negative 26 because 27 is larger. And look what I have. On the left-hand side, I also had a negative 26. So I actually just found my answer, and I know that because at the very end of the problem, I got the same thing on both sides of the equal sign. So I have to go back up to the top and look, what was I trying? I was trying letter B, x equals negative 3. I ended up getting the same thing on both sides of the equal sign. So that tells me x equals negative 3 is actually my answer. And on the test, I could put that answer in and confidently move forward knowing I got that one correct. Alright guys, so here's the part of the video where I want you to try the problem. So you have up here this problem with these multiple choice options. I want you to go ahead and try and see if you can come up with the right answer. So pause the video and try it, please. All right. Hopefully for your answer you tried plugging in the value of 1, which would have been C, x equals 1, and you would have gotten the answer right. So give yourself a big pat on the back if you were able to get that. If not, look through the problem and see if you can find your mistake. Okay, let's move on to another example where we would be doing a plug and chug. The question is find the solutions to the equation, or they could also say find the value or values that make the equation true. You know this is a plug and chug because if you look at your answers, again, they are all x equals a number, x equals a number. In this case, we have two answers because we're dealing with a quadratic. The problem with this question is most kids take both answers and plug them in at the same time. But you have got to remember that only one value or one number goes in for x at a time. So down here I've got 1, 2, 3, 4, 5, 6 unique questions because the 6 and the 2 are found over here. I've got 6 options I could go through, but I'm going to do them one at a time. So let's first start off with x equals 2. Remember, everywhere you see an x, which are these two spots, I'm going to take out that x and replace it with a 2. Now that I've plugged my 2 in, I'm going to go ahead and start doing order of operations. Remember, you can work on the left side independently from the right side. So I'm looking at my left side. I don't have any parentheses. I mean, I do have parentheses. You can consider these to be parentheses right here, but there's only one number inside of them, so I really don't have parentheses in that situation. But I do have an exponent, and that exponent represents multiplication, so I'm going to go ahead and box that in blue. On my right side, I also have multiplication. So I know on the left, I'm back on the left side, 2 to the second power is 4, and 14 times 2 is 28. So now bring everything else down that's in black. And let's continue looking and working through order of operations. And so I'm going to write order of operations up here real fast. PEMDAS. So on our left-hand side of the equal sign, I've got multiplication and subtraction. So I've got to do that multiplication first. So I'm going to box 7 times 4, and I know 7 times 4 is 28. Bring everything else down. And looking at this, I'm going to box this in green because it's got a minus sign in the middle of it, and I know I can do that with the green box for adding and subtracting integers. Now I have a positive 28 and a negative 105. So because they have different signs, I'm going to subtract those numbers. 105 minus 28. Well, I know I can't do 8 from 5, so I make that a 9. 15 minus 8 is 7. And 9 minus 2 is 7. So I know my answer is going to be 77 over here, but it's going to be a negative 77 because 105 is larger than 28 and he's negative. So it's going to be a negative 77. Does that in fact equal 28? And no, it does not. It does not equal 28. So what does that just tell us? I now know x equals 2 is not an option. So anywhere I have x equals 2, I can go ahead and mark that out. That's what's kind of nice about this one. I had an x equals 2 there. He's no longer an option, so mark him all the way through. And I had an x equals 2 there. So that's no longer an option, so I can mark that all the way through. I'm going to go ahead and try a positive 8 and a positive 6. But I'm going to first do the positive 8 first. So I'm going to take 8 and plug him everywhere I see this 2 or everywhere I see an x in the original problem, and then chug my way through that problem. Now that I've plugged in that 8 everywhere I see an x, I'm going to chug my way through the problem. If you want, I'm going to do it real fast. If you want to try it on your own first, then go ahead and pause the video and see if you get the same thing I got. Alright, if you got down to the very bottom, you hopefully ended up with the answer of no. If you kept everything on the left-hand side, you should have ended up with 343, and then on the right-hand side should have been 112. So that tells me now that A is not an option, D is not an option because of the 2, and I just tried 8, which means that is not an option. So I'm just going to confirm that B is the option by plugging in both of those values, but at separate times. So if you want to try some more order of operations problems, pause the video and see if you can come up that -3 and 5 would be the solution. But remember, only plug one in at a time. So I'm going to go ahead, I'm going to plug -3 into both those spots and chug my way through it, and I should get a balanced equation. And then I'm going to also do the same thing with 5. So if you'd like to try that on your own, pause the video and you can try that. So looking at the answers, we got a balanced equation when we plugged in -3, and we also got another balanced equation when we plugged in 70. Awesome job with this one, guys. Let's move on. Oh, so sorry. So I guess I should have wrapped it up. The answer to this would be B then. And you could answer it with that and confidently move forward knowing you got it correct. Here is a you try problem. If you want to go ahead and pause the video and try, you are more than welcome to. There is one mistake in this though. This answer up here should have been a -3. Sorry, that should be a -3 and not a +3. So as you're looking through this problem, I know you're seeing fractions at first and you're freaking out. So don't freak out with the fractions because look at all of the whole numbers. Those are all different numbers. 1, -2, -3, 3. So when you're trying these problems, just try the whole numbers to see which one works, and whichever one works would be your solution. So go ahead and pause the video and try it, please. Okay, here's the solution all worked out. Hopefully you guys got D as your solution. When you plug in a +3, you get 0 equals 0, which is awesome. When you plug in a -3/2, working all the way through the problem, you also get 0 equals 0. At this step in the problem, I did change it to decimals. So that was something that you just divide 18 divided by 4, and that would give you 4.5. Same thing with 9 divided by 2. Okay, another time you're going to use that plug and chug strategy is whenever you're given a point in a problem. And the reason why this all of a sudden becomes a plug and chug is because you now know, given a point, that x is equal to 3 and y is equal to -2. So let's go ahead and write that down. X equals 3 and y equals -2. So everywhere in the problem we see an x, we're going to replace it with a 3. And everywhere we see a problem with a y, we're going to replace it with a -2. So let's start with this first one right here. 3y plus x equals -5. So I'm going to write 3, but instead of a y, I'm going to plug in -2. And then I'm going to continue writing the problem. Plus x, but instead of x, I'm going to plug in a 3. And then that's supposed to equal -5. So doing order of operations, I see multiplication right here. 3 times a -2 is -6. And then I have just a +3. Is that in fact equal to -5? This would be my green rules. So if you owe me $6 and you found 3, you unfortunately still owe me $3. So ask yourself, does negative 3 equal negative 5 or equal 5? And no, it does not. So since we tried the very first equation in this system of equations, because that one didn't work, the whole thing isn't going to work. So A is not going to be an option. Let's try B now. So we have 2 times y, but instead of y, we're plugging in a negative 2, and we know that because of this point right here. And then we're going to add an x, or add 3, and does that equal negative 1? So I have multiplication first. 2 times a negative 2 is negative 4, plus 3, does that equal negative 1? If you owe me $4 and you found 3, unfortunately you still owe me 1, so that's going to be a negative 1. And it did work for that equation. So let's plug it in the second one and make sure it works for there. 2 times x, but that would be 3 in this equation because of the point. So 2 times 3 minus, I'm plugging in the y of negative 2. Does that in fact equal negative 2? So we have multiplication here. 2 times 3 is 6. And this is also multiplication because you could see this as a negative 1. And a negative 1 times 2, a negative 1 times a negative 2 is a positive 2. And do I have 6 plus 2 equals negative 2? Does that work? No, it does not. So even though it worked with the first one, it didn't work with the second one. And that's how you know that that's not going to be an option. So let's go try C. So I have 3, and instead of y, I'm plugging in a negative 2, minus x, so that would be minus a 3, and that equals, hopefully, negative 9. All right, I've got multiplication here. 3 times negative 2 is negative 6, and then I have minus 3, so I can just go ahead and write that down. Minus 3 equals negative 9. And on the left-hand side, I'm going to box that in green because I see that, I'm going to box it in green because I see that minus sign in the middle. And I have negative 6 minus 3. I have a negative sign and a negative sign. Since they both have the same signs, I add those numbers, and that gives me 9. And the negative stays all the way through. So does negative 9 equal negative 9? Yes, it does. So it worked for the first one. Let's see if it works for the second one. 2 times y. So 2 times negative 2 plus 5 times x, or 5 times 3, does that equal 11? So I have a multiplication here. 2 times negative 2 is negative 4. And then I also have a multiplication here. Positive 5 times a positive 3, which is positive 15. So I have negative 4 plus 11. I have negative 4 plus 15, where if I add those, I'm going to box them in green because I have that plus sign. They have different signs. One is negative, one is positive. So therefore I subtract those numbers. 15 minus 4 is 11, and it's going to be a positive 11 because 15 was larger. So 11 does in fact equal 11. Yay! It worked for both of them. So since it worked for both of them, my answer is C. And you just got a lot of points for this problem because it's a systems problem, and you know you're right. Let's move on to another one. All right, so here is a you try. I want you to go ahead and try this one, and the reason why this one is a you try is because it's given you another point. So we have the example is, or the question is, which of the following is the equation of the line that passes through the given point? And once you see that point, you are super, super, super happy because you now know that x is equal to 5, y is equal to negative 2, and you really could care less what the problem is about. You could do some strategy and understand what slope means and understand which one of these numbers is slope and how is that important. But if you cannot remember that on the test, you can remember plug and chug. So we know that we are given a point, and we're going to plug that into every single one of these equations. So go ahead and pause the video, keep plugging until you get that right answer, and check to see if it's right with me. Okay, hopefully you were able to make it through the problems and you got choice D as the correct one. If you did, give yourself a big pat on the back. You guys are doing great. Keep it up. Okay, so here's another systems equations. If you're looking at it, you've got a big system up here. And the answers could look like this, where they tell you specifically x equals 8 or y equals 6, or it could be given in point form. Either way, you're super happy because you were given a point, and because we're given a point, we now know if we're trying letter A, we know x is going to equal 8, and y is going to equal 6. And this time, all I have to do is plug it into one system right here. So plug in x equals 8, so plug in 8 here and 6 here, and hopefully we get a balanced equation. Do the same thing below there. Hopefully we get a balanced equation. And we would then select A as my answer. But if that does not work, then you're going to keep trying the rest of the problems. So pause the video, try this one, and see how you do. Okay, hopefully you were able to try the problem and you got to choice B as your answer. If you did, give yourself a big high five. You guys are doing excellent with this strategy. Okay, another time that you could do plug and chug, and it's going to be the plug and chug method, but like I said at the very beginning, this is actually still real math because you're plugging in the answers, you're chugging your way through by following order of operations, but notice we don't have an equal sign in the actual problem itself. That's what should trigger you to let you know that, oh, this one's different. It says evaluate, and yes, I am going to be plugging and chugging, but you're not going to know for certain whether or not you got the answer correct. You're just going to hope that you did all the order of operations correctly and that you ended up in the right spot. So if this problem, everywhere we see an A, we're going to plug in -4. We're going to plug in a -2 for B and a 4 for C. So looking at my problem, it's going to be -4 parentheses, -4 minus -2 parentheses plus 4 parentheses closed. Be very mindful in this spot right here that you have both of the negatives. This negative is coming from the subtraction up here, the subtraction sign, whereas this negative is coming from b equals -2. So make sure both of those are there in the problem. Okay, order of operations it up. Let's put PEMDAS over here just so we have it as a reference. Parentheses, exponents, multiplication, division, then adding and subtracting. So inside my parentheses, which is right here, I have this multiplication, right? I have the double negative sign. So I'm going to box that in blue, and I know that a -1 times a -2 is a +2. And I'm going to bring everything else down that's not inside that box. And then I'm going to look back inside the parentheses and work left to right. I have a -4 plus 2. So I have two different signs. One is negative, one is positive. And I know I need to subtract the numbers when that happens. And if I do 4 minus 2, I get a 2. But in this case, it's a negative because the larger number was also negative. So I have -4, bring everything else down. And I'm still working inside those parentheses. I have -2 plus 4, and again I have a negative number and a positive number, so I'm going to subtract them. But this time it's a +2 because my 4 was the larger number and he was positive. So my very final thing I need to do is -4 times 2, which gives me a -8. And looking up there, I have an answer choice of -8 for B. So this is what I was saying. You don't know for certain whether you got it right because I'm going to let you know PERT's going to put the common mistake answers there as well. But at least you know that you're plugging it in correctly and you're going to follow order of operations to the best of your ability and hopefully get that right answer at the very end of it all and feel great about yourself. All right, let's move forward. Okay, so here is a U-try. This is the last U-try of the whole entire notes video. So go ahead and pause that video, try this one, and see if you can get the right answer. All right, hopefully you got a -2 as your answer. That would be great if you did. You guys, I know this was a long video, Awesome job sticking all the way through it, and hopefully if you pay attention to the plug and chug, you'll be able to get that score you want on the PERT, and which is why these videos are made. So thanks for watching.